Hello, welcome to Artificial Intelligence Hub. Today I'm gonna teach you how we can make a Flask app to classify for classification to classify the images. So here you can see here is the Flask app. When I'm gonna run this app, so here so you can see here is when I gonna run this app, just passing some input here. So it will predict the object. So this is the dog. So when I'm gonna pass this image, so it will predict the output of the image. This is the Flask app. So here when I'm gonna write about, so here is my about section. Please subscribe Artificial Intelligence Hub. So here is the main page. So in this lecture I'm going to teach you how we can build that particular kind of app to classify images, any kind of images. So for that you need to first train a model using a tenserflow or keras library, and then deploy that model on into the Flask app. So let's start here. So let's start it. So I just have opened my Google Colab notebook. So here is the app. I already wrote the code. I'm gonna tell you. So here is the dataset. I just took two classes for that one. So in my dataset I have two classes, cat and versus dog. I mean, first is cat and the second one is dog. So I just took 100 pictures for cat and 100 pictures for dog for demonstration. So here you can see 100 pictures of dog in this dataset. So here is the code. So for that I'm gonna remove this one. This is the model generated. So I'm gonna go here and just first of all we are going to train a model on using cat and dog images. So first of all you need to mount your Google Drive here. So I'm using a Google Colab. So first of all you need to check, is it on GPU, you are using GPU or not. If it is it okay, fine. After that just mount your drive with notebook, a Google Colab notebook file. So here I'm just mounting this one. Just wait for a while and then start it for. So far after mounting the drive, I'm just gonna find the app here in my drive. So here is the app. I'm just copying the path of this, and right here I'm just writing cd, paste the path of that particular folder, and after that I'm gonna just downing the TensorFlow version. So here the Colab version is 2 point something. So for that, when we're gonna train the model and deploy into the for Flask app or our laptop, so the weights file and the model file will sometime not work. So that's why I'm gonna downgrade my TensorFlow version. Here that you can see when I run this command, so it will select it 1.15.2 version here. So it will downgrade the version. So after that I'm just gonna call import. I just have import cv2 and os for accessing my directory. So here is the path of my dataset. This one I'm just copying this one and paste here. So after that it will show the categories, how many categories in that particular folder. If you can see here, I have just two categories, cat and dog. So here it will make a label dictionary. Here you can see a label dictionary. When I'm gonna run this one, so it will show me the classes and labels here. So after that I'm just taking the input size of image is equal to 100 and making a two lists, one for taking numpy arrays of data, and second for labels. Our target one is the for label. So here is the loop is running on this particular categories. So it will this loop will take the image and convert into the numpy array, and will store and here, and the labels are here. So you can see here, So here is the function which will run and take images and store into my two lists, images and the label one. So when I run this one, so it will took each image by image and save in to this dictionary and these two dictionaries. So it takes some time here. So you can see here, so I'm just resizing image into 100 by 100 and then append image with in this list and target in this list. Category means 0 and 1 and labels are saved in that target. And after that, so I'm just waiting here. So after completion of this loop, so I have my data in this list and label in this list. I'm gonna show you here. So I'm just gonna run the data here, so it will show you some. So here is my data, images and targets. So when I run the target one, so you can see here are the targets. So labels 1 1 1 0 and everything 0 0 0. So I'm gonna remove this cell, and after that, so here what I'm gonna do, I'm just rescaling preprocessing, applying some preprocessing, rescaling the images into 0 1 values. I'm just taking images and divided by 2 5 5 6, so it will give me the range between 0 and 1. So also reshaping the images into 100 by 103 scale. So you can see I'm just after rescaling, I'm just reshaping, and here is target dot np. So here just I'm converting the label into the numpy, and after converting the label into the numpy, I'm just do some new, I'm just converting that images into labels into the categorical cross entropy. If you can see before that one, so the labels are in the form of 1 2 values, binary values, 1 and 0, 1 and 0. So here what I'm gonna do here, I'm just gonna convert into categorical. After that, you can see how the labels looks like. So here are the labels in the form of 2 categorical. You can see 0 1. So they convert the labels into the form of categorical and you can see that each list has contained 0 1 0 1. So after that, we're gonna check the shape. So we have total 200 images, 100 for dog and 100 for cat, and the classes are 2. So I'm gonna check the data images. So I will have 200 images also, and 100 by 100 and 3 means we have 3 channel. So here is the model. So I have just made the model a CNN model. So which contain in first layer it has 200 convolution operations with 3 by 3 filters, and input is 100 by 100 and ReLU, and then after that max pooling, and this is the CNN model. At last layer I have 2 dense layer. I have 2 neuron with output cat and dog, and here is activation function. I'm using softmax. So for compiling, I'm using the loss function, categorical cross anisotropy, and optimizer is equal to Adam, and matrices is equal to accuracy. So after that, when I run this one, so here is a model summary. Here is the model summary, and after that I'm just splitting the data into training and test. So I'm taking the 10% of test here using sklearn.model selection import training test split. And after that, when I run this one, after that you can see here for training we have 180 images, and here I'm gonna run a number of epochs up to 200. So when I go run this cell, so it will run the command here and process the images and up to 200 epochs. So here are the training images. We have 144 sample, and validation we have only 36 sample per epoch. You can see here. So it's running. So after completion of training, here I'm gonna save my model. So let me remove this one. So I'm gonna save my model. Here is 200 epochs. I have got 100% training accuracy, and validation accuracy is up to 61%. I'm just using a quite low data set. The data has we have a limited data set here, 200 images. That's why. So you can use it according to your needs. You can use a lot of data set. I'm just for the sake of how the app will work, I'm just taking a small data set here. So after that, I'm going to save that one. After saving, I'm just going to plot my accuracy here, total 200. I'm just run up to 200. When I run this one, you can see here, so how the graph looks like. It's quite bad here. So you can see we have a validation loss up to here, and accuracy training loss up to here. So you can definitely see it's the model is trying to overfit, because we have a limited number of data. That's why it's doing overfit. So we can remove it by adding more number of images, so it will give us a good result here. It will not do overfitting. So here you can see here, when I refresh this one, so we have got model file, model.h5 here. You can see here I have a model.h5. So I'm just gonna download this one into my local drive. So I did it, so I'm gonna show you here. You can see here I have model in my Flask app. So here is the Flask app. So I have my model here. So here is the code for Flask app. So for that app, you can see here, I just first of all you need to make sure you have install Flask in your machine. So I have already installed, that's why it's showing me you have already in your machine. So after that, you can see here, first of all you need to import Flask functions, render, template, request, and keras function, keras.models, load the model, keras.preprocess3 libraries. So here is how to write the Flask. So here is, I have just made the dictionary, 0 for cat and 1 for dog, and here I'm just gonna load my model in. After that, you can see here model dot prediction. This is a function of use for prediction. So here is a function, a prediction label. So for what the purpose of this function will take the image and resize that image into 100 by 100. Actually we have trained the model on 100 by 100 images, so that's why for the prediction we need the same dimensions. So after that, I'm gonna rescale that image, which I'm gonna upload it into the browser, and it will get that image and reshape that image 100 by 100 in 3 RGB scale, and then pass to the model predict class. So the model.predict class, and here is the image. So it will give us the probability of a particular image and detect which class it's belong here. So after that, this is the function here. When we run the app, so it will call that function here. Just rewrote this function. So this is the main function, app.root. When we run the app, so it will call this function. It will go to this function and find app.root._. So when the app will run, so it will automatically find this index.html file. So here is the index.html file in my templates, index.html file. So after finding that index.html file, so here is the button. So when I'm gonna show you, when I open this file in my when I click and open this one, so you can see here submission. So here is a submission button. So here is the form. So the form is here. When I perform some action, so it will automatically call here. So when I press this one, so it will automatically call here. So this is the label, and action is equal to submit. When someone click on the button, so action will be performed, submit. So here you can see root.submit and get and post. It will take that image and call this function, and this function will take the image and predict the output. So for that, when take the image and save that image into the static folder and call this function. So here prediction will be called, and it will give a dictionary result, cat or dog, and this will thrown to this page. So here is the probability and image path. So it will throw the image and the probability of the image, and so here the output and prediction value which will comes from there and will show here. So I'm gonna run here how the app will work. So when I run this one, so here I'm gonna just go into my drive and press right here. So you can see here it's working. I'm just gonna pass this image here. So let's see. So here is the output. The image show that this is a cat. So I'm just gonna take this image and run again. So it say this is dog. So this is the app. When I'm gonna write about, so I have also write the function name with about, and it will show about something. When I write some about, so it will show me please subscribe Artificial Intelligence Hub. So this is the app, how the app works. You can take your dataset, you can run any kind of dataset on your Google Drive on your local machine and deploy that model here and write your classes here 0, 1, 2, how many classes you have, and run this Flask app. So it will give you the result. So I will upload this code on my Google GitHub repository. You can access that code from here also. So far, thank you so much for watching this tutorial. Please like and subscribe my channel.